Alright, here we go. So yesterday we talked about finding the percent composition, and we left off talking about a hydrate, right? So let's say I gave you, where's my scrap paper? Let's say I gave you aluminum fluoride, 3 H2Os. You guys are green. And it's 1,725. Okay, and I tell you that I want you to find the percent of water in this hydrated salt. How would you go? You can't see a darn thing, can you? Nope, you cannot. Why is it not showing? Ah, there we go. Now we're all no, it's not better. Yeah, it's frozen. Now we're better. Okay, what about if I wanted to find the percent of water in that hydrated salt? How would I do this? I gotta find the gram formula mass. So, just to visualize one more time, I'm not doing this again after today, just to visualize, we're gonna draw the aluminum fluoride. And how many water molecules do we have attached to it? 3. It's trihydrate. Okay, I've got 3 water molecules here. I'll highlight them. I'm going to do 1, 2, 3. And I've got my salt in the middle. This is called a hydrated salt. It's hydrated because it has these waters on it. I want to find the gram formula mass of the whole thing. Let's start with the aluminum fluoride. Just this blue part right here. Aluminum, there's 1 of them, it weighs 27. Fluorine, there's 3 of them, they weigh 19 apiece. That's 54. Okay, that whole thing is going to weigh or add up to 84 grams. That's just the aluminum fluoride. Check my math. 7, 8, 9, 10, 11. That is not right. This is what happens when you go by memory. All right, let's do 19 times 3. Oh, where's my calculator? 27 plus 19 plus 19 plus 19. 84. What's 3 times 19?
I got you. No.
Aha, there's my mistake. Okay, that's why we need to work together.
Anybody else need a calc?
So that we get the right answer. Megan needs one. Stop talking and let's all focus. Alright, so this is what the 84 grams is. This is just the aluminum fluoride. How many water molecules do we have? 3. And how much does each water molecule weigh? 18. 18 times 3 is 54 grams. Alright, so the blue is this 84, and we'll make the orange the water. So these 3 water molecules add up to 54. What does this whole Megillah weigh? 138 grams. Okay. Now I want the percent of water in that hydrated salt. So we're going to take part which is water, which is 54, the part that is water, over the whole thing times 100, that's my percent formula. The part that was water was the 54. The whole thing weighed 138 times 100, and you should get 39% water. Check my math.
Yeah.
Yes? Do you understand what I just did? Okay. Now, this is new. Let's say I hand you a bucket. This is a bucket. And in that bucket, I give you the aluminum fluoride trihydride. In that bucket, I'm telling you there's 100 grams of the aluminum fluoride trihydride in it. How much of that is water? How many? 39 grams. Because 39% of whatever is in this bucket is water. If I change this to 649 grams of aluminum fluoride trihydride, now how much water is in that bucket? Since I just made it up, I better type it into my math maker here. How many? That's what I got. Okay? It's 253 grams of water that's in that bucket. How did you do it? Times 39%. Because, stop talking, 39% of 649 is what we are looking for. When you think of it like this in a sentence, the word of means to do what? Try again. Multiply. And the word is equal to. So 39%, we're going to change that to a decimal, of 649 equals, and then we get 253 grams of water in that. So it doesn't matter how much stuff you have, as long as you have the percentages, now you can figure out how much water or how much salt you have in your sample. Understand? Yeah. Let's try another one. I don't know if I did this one with you yesterday, but let's do this. I'm going to change it up just a little, even if I did it with you yesterday. Alright. I've got magnesium chloride tetrahydride. Tetra meaning 4 waters. Let's say that I give you a sample of 48 grams. How much of that sample is water? How do you figure this out? Yeah, the calculator. So what do we do with the calculator? Okay, keep going. You're just saying things randomly. Part, whole, whatever. Alright, so if I put the formula down that you're telling me to put down, part over whole times 100, what numbers go in where the P and the W are?
The mass of water.
Okay, so where's the mass of water?
On the right.
Alright, can we start over again? Okay, so we're going to find the gram formula mass of the whole thing. So let's do magnesium. There's one of them. It weighs 24. Where's your reference table, Walters? Chlorine. There's 2 of them at 35 apiece. That's 94 grams. I've got 4 waters at 18 grams apiece. 18, 18 is 36, 36 and 36, 72. So 72 grams is water. Does everybody know where I got those numbers from?
Yeah.
Okay. So what is happening here is the whole thing is going to equal 94 plus 72. That's the whole thing. So what's 94 and 72? 94 and 72 is not 66.
166.
166. That's better. All right. 166. All right. Now, how do I find the percent that's water?
You have to find just the mass of water.
Okay, what is just the mass of water? Nobody tell him. Walters, what's the mass of water? Yeah, oh God is right.
The mass of water is 18.
That's 1 mole of water. How many moles of water do I have? 4. I have 4 18. So what's the...
72.
There you go. 72 grams over, what does the whole thing weigh?
166.
166. Don't move until I'm done. Okay, 72 divided by 166. 43%?
Yeah,
Does that sound about right?
sounds about right.
43% water. All right, go. And then when we come back, we're finishing this.
Got it right.
Okay, focus. Put your phones away. Focus.
Phone's away.
Okay. I told you that you had a sample of 48 grams, and I wanted to know how much water you had. What do you do now? Thank you. 43% of 48 is going to be your water. So 0.43 times 48. Get my handy dandy math maker out.
I got 20.6.
20.6?
So 21.
I'll leave it 20.6 just because I feel adventurous today. And that's going to be 20.6 grams of water. Any questions on this? Okay. All right. What we've been doing now is taking grams and making them into percents. Now we're going to flip it. We're going to take the percents and we're going to turn them into a formula. So let me just explain to you here. When you have a formula like H2O, okay, this number here and this number here that's not written in, the 2 and the 1, that's called a mole ratio. It's telling you I need 2 groups of hydrogen for every 1 group of oxygen. It's a mole ratio. Boys, pay attention. Okay? So, there's 2 hydrogens for every 1 oxygen. If I tell you that this thing is made from 11.1% hydrogen and 88.9% oxygen, how do I get it to tell me what the mole ratio is going to be? I have percentages here. I need to get them back to moles. Can I use grams to get to moles? Yes, sirree, Bob, I can. Do you remember what the formula for moles, grams to moles was? Grams over gram formula mass. Okay, so this is what we're going to do. I'm going to actually change these just to make our life easy. 11% hydrogen and 89% oxygen. Okay, just make our lives easier. Just rounding these. Okay, the first thing we're going to do is we're going to take the percent and we're going to assume that we have 100 grams. If we have 100 grams, then 11% of 100 grams is going to be 11 grams, correct? Okay. 11 grams of hydrogen and 89 grams of oxygen. So all we did was change percent to grams. That's the easiest step. All you have to do is change percent to grams. Now, how do I change grams to moles? William, tell us again the formula. Grams over gram formula mass. We have grams. What's the gram formula mass of hydrogen? 1. 11 divided by 1 is 11. So I have 11 moles of hydrogen. Now let's do oxygen. Oxygen, we have 89 grams. What's the gram formula mass of oxygen? 16 grams per mole. What's 89 divided by 16? 5.6. All right, good enough. 5.6 moles of oxygen. Okay, so right now, all I have is moles of hydrogen and moles of oxygen. Look at how beautiful that color is. Okay, remember that these numbers, the 2 and the 1, are moles. So if I didn't have those numbers, they would be X and Y. 11 would be the X, because that's the hydrogen. And oxygen would be 5.6. That's a mole ratio. I need 11 moles of hydrogen for every 5.6 moles of oxygen. Is this an empirical formula? What does an empirical formula mean? Simplest whole number ratio. These are not whole numbers, right? It's definitely not simple. They're ugly. Ugly numbers. So the last thing we're going to do is we're going to clean this up by taking whatever the lower number is. In this case, it's 5.6. And we're going to divide both of those numbers by 5.6. 11 divided by 5.6 is 2. And 5.6 divided by 5.6 is 1. And you get H2O1 as your empirical formula. So let me go through those steps one more time. We changed the percent to grams. We changed grams to moles. That gave us the subscripts, but they were ugly. And then to get rid of the ugliness factor, we divided by whatever the smallest number was to make it an empirical formula. Okay, let's try another one. Let's say you had 75% carbon and 25% hydrogen. And I want to know what the empirical formula is for this substance. I know it's 75% carbon and 25% hydrogen. What's the first thing I do? Change them to grams. So 75% becomes 75 grams, and 25% becomes 25 grams. Sometimes, folks, they don't even have you do that. Sometimes they just say you have 75 grams of carbon and 25 grams of hydrogen. Then you just skip that first step. They already gave it to you in grams. All right, what do I do next? Find the moles. We have the mass. Moles is grams over gram formula mass. How many grams do I have? 75. What's the gram formula mass of carbon? Don't guess. 12. Okay, 75 divided by 12 is 6.25. So I have 6.25 moles of carbon. All right, let's do the hydrogen one. Moles equals grams over gram formula mass. I have 25 grams. What's the gram formula mass of hydrogen? 1. Moles equals 25. Okay, so now what I have here is I have C and H, which X and Y. We don't know what those numbers are. But X is going to be the moles of carbon, 6.25, and hydrogen is going to be the moles of hydrogen, which is 25. Is that an empirical formula? No. How do I get it to be empirical? There we go. Now we're cooking with some gas. 1 and 4. CH4. Got it? Nora, you with me? Okay. 52.7% potassium and 47.3% chlorine. Tell me what the empirical formula is. Okay, here we go. Answer time. So, 52.7%. We made it 52.7 grams. 47.3%. We're going to make it 47.3 grams. We're going to change 2 moles. We're going to take grams over gram formula mass. 52.7 grams over the gram formula mass of potassium is 39. And what's 52.7 divided by 39? 1.4? Okay. That's moles of potassium. I'm labeling it. All right, 47.3 grams over 35 grams per mole. You should also get 1.4 or something really close to that. Okay, moles of chlorine. That means K is 1.4 and Cl is 1.4. I'm going to take the lower of the two, whatever it happens to be. In this case, they're the same. And we're going to get KCl. That's my empirical formula. Okay. Now, this one that we were just talking about is a little bit trickier. Let's do FeXO3. Oops, not O3. OY. I just gave you the answer. Okay. And let's say that you have 70% iron and 30% oxygen. We'll work this one through together because this one has another little trick to it. What's up? Yeah, sure. Go ahead. Yeah. All right. 70% is 70 grams over 56 grams per mole. We're changing it to moles. So 70 divided by 56, and you get 1.25 moles. Oxygen, you got 30 grams divided by 16 grams per mole. .875 moles of oxygen. Ready? Move on? Okay, so you now know that iron is 1.25 and oxygen is 1.875. That's ugly. We're going to divide through by the smallest number. And we're going to get 1 and 1.5. So Fe and O. That's still not smallest whole numbers.
Will it take double it?
Yes. So because this is right smack dab in the middle, you don't round down or up. You would have to double everything to get rid of it. So Fe2O3. That's the key right there. If you get something that's not close to a whole number, you must double it to get rid of them. Okay? All right. Are we getting the hang of these? Okay. Let's try this one. 32.4% sodium, 22.5% sulfur, and 4.5%, I lied, 45.1% oxygen. What's the empirical formula? You got 3 now. Same steps. Let me shut this off so we're not listening to it. Find out. Megan's going to tell us. Go. Basically. Nice and loud so we can all hear you.
You gotta find the gram formula mass of each element. Okay, you gotta turn it to grams first.
Okay, how do I do that?
Get way.
Yes. They're all based on a 100-gram sample. Okay, I changed them to grams. Now what do I do?
So now you have to get the gram formula mass of each one.
Okay, and what am I doing with that?
You're gonna divide the percentage by the gram formula mass.
Okay. So we're going to find, and when we do that, what are we finding?
You're finding the epicural one. You're finding how much it's into moles.
You're finding moles. Good. All right, so 32.4 grams divided by, what's the gram formula mass of sodium? 23 grams per mole. What'd you get?
I got 1.4.
1.4 moles of sodium. Okay, do the same for sulfur.
You have to divide it by 32.
Okay.
0.7.
0.7 moles of sulfur.
And then you got divide that one by 16.
And what'd you get? 2.8 moles of oxygen. All right, so here are our numbers that we're working with. Stop talking. I'm starting to get annoyed. Okay, we got 1.4 moles of sodium, 0.7 moles of sulfur, and 2.8 moles of oxygen. So we're going to write them in. 1.4 moles of sodium, 0.7 moles of sulfur, and 2.8 moles of oxygen. Now what do I do? Yeah. So how do I do that? Okay, so 1.4 divided by 0.7, 0.7 divided by 0.7, and 2.8 divided by 0.7. Yep. And there is my empirical formula, not whatever the word you just said before. Say, I can't hear you because they're being loud. No, because there's a 2 here. 2, 1, 4 is the lowest whole number ratio. There's a 1 there. That's a good question. Okay? All right. Last one for today that we're going to do together is going to be 25.3% copper, 12.9% sulfur, 25.7% oxygen, and 36.1% water. Okay? Now, notice that I said water here. Okay? So, I am looking for the formula for the hydrated salt. Remember what a hydrated salt looks like? It kind of looks like this. Salt, dot, and then there's a number, and then there's H2O. Okay? So I am looking for the salt. In this case, the salt's going to be Cu, S, and O. Just watch. Cu, S, and O. I don't know what these are. I don't know what those subscripts are. I've got a dot, and I've got an X. It's not the same X. Let's make it A. Okay, because I used X there. H2O. That A is how many groups of water you are going to have in your salt. It's moles. Okay? Sometimes people will write it like this, H2O, and then they'll put the A down there. Just, it's the same thing. It's how many groups of the water I have. Okay? So you are looking for X, Y, Z, and this A. X, Y, Z, and this A. Go ahead, try it. Okay, answer. Did we get an answer? What is it? CuSO4 dot 5H2Os. Is that correct? Okay, let's work it through for those of you who are still having trouble and for the videotape. Okay, we changed this to grams, so we got 25.3 grams. Divided by 64 grams per mole. That's going to give us moles. How many moles is that? Don't put your stuff away. I'm not done. 25.3 divided by 64. You should have it on your papers. 1.4. Okay. 0.4. 0.4 moles of copper. What about 12.9 divided by 32, which is going to give us moles of sulfur? 0.4 moles of sulfur. 25.7 grams of oxygen divided by 16 grams per mole. 1.6 moles of oxygen. And 36.1 grams divided by 18 grams per mole. 2. All right, so we've now got CuSO and we've got H2O. Okay, I'm going to put it down here for now. X, Y, Z, and A. X we know is 0.4, Y is 0.4, Z is 1.6, and A is 2. How do I get these numbers to be nice, even, whole numbers? 0.4, 0.4, 0.4, 0.4. So this is 1, 1, 4, so CuSO4, and 5 H2Os. Okay? You got this? That's fine. 5 can go there, or 5 can go there. I prefer it in front, actually, over in the subscript position. Doesn't matter. Any questions? If you put the 5 out here, that water needs to be in parentheses. If you don't put it in parentheses, it matters. Okay, how much time do I have left? I have one more thing I want to do.
7 minutes.
All right. No, we're not talking for 7 minutes. Listen. Let's say, because this is what the lab's going to be on Thursday, we are going to give a sample of a salt, a hydrated salt. This is what you're going to get. And you're going to measure that sample on the balance. Let's say it weighs 92 grams of the hydrated salt. Okay? Then I'm going to tell you, you're going to heat it up. When you heat it up, what's going to happen to that hydrated salt? It's going to get... It's going to get hot. And what's going to happen to it? It's going to evaporate the water. Good. So, essentially, we're taking the hydrated salt, we heat it up, and we're going to end up with an anhydrated salt. An means without water. Okay? That's a fancy way to say without water. So this salt has the water. This salt does not have the water. So let's pretend I already walked over to my my hot plate. I evaporated the water off of it, and now it weighs 58.88 grams. If I have the salt with the water, and I have the salt without the water, can I figure out how much water I have? How do I do that? Subtract them, and how much water would have been lost? 0.12 grams of water. Okay, now I want to find the percent of water in my hydrated salt. So how do I find the percent of water in this? Go ahead.
33.12 divided by 92 over 100.
Perfect. All right, so my percent of water is going to equal the part that's water, and we just figured that out, 33.12, divided by the whole thing, which is the 92, because the 92 is the salt and the water together, times 100. Whoops, I kind of messed that up. 33.12 divided by 92 times 100. And what percent of water do I get? 36%. Okay. Now I have 36% water. If I have 36% water, how much salt do I have? In percent? 64% salt. Okay? You good so far? Okay. So let's say the salt is CuSO4. Let's just say it is. Okay? And we have 64% salt, 64 grams of salt, and 36 grams of water. What's the mole ratio from here to here of moles of copper 2 sulfate to moles of water? How would you do that? (64) divided by 160. That's what this whole thing weighs. That's the gram formula S. And you're going to get moles. How many moles do you have? 64 divided by 160. 0.4. And then 36 divided by 18, which is going to give us 2. That's 0.4 and 2. How do I get them to nice whole numbers? Divided by 0.4, and you're going to get 1 and 5. Does that look familiar? Yeah, 1 and 5. We did it already. But we didn't do it with numbers that you're going to get from lab. You're going to get your own numbers from lab, and you're going to have to prove that there are 5 moles of water for every 1 mole of copper 2 sulfate. How are you going to do that? You're going to take your little sample, and you're going to take the water off, and you're going to take the water off of that salt. You're going to find the percent of water that you took off the salt, and you're going to make them into moles, a molar ratio of moles of this to moles of this, just like we did in class. Do you understand? Okay. Good. All right. Now we're done.